thereabouts. Sometimes it's not 240, sometimes it's about 220 volts, and sometimes maybe 200 or 180, but standard it's meant to be 240 volts. Now the question is, this 240 volts you get from your PHCN, formerly PHCN, or IBDC, public power supply. What is this 240 volts? Is it VPEAK or VRMS? That is what we'll be examining next now. Is it this or this? Question mark. Now the power supply that you get from your public utilities, like your IBDC, it takes the normal shape, it follows the normal shape. Let me draw that again. Now, the 240 volts you're measuring with your multimeter, or that you most likely measure with your multimeter, is actually your VRMS. The truth is that the voltage from PCN or from IBDC, the peak of that alternating current voltage is not actually 220. It goes far beyond 240. Sometimes it reaches as much as high as 340 volts. Briefly, it goes beyond 240, goes as high as 340 volts, around this range, and then drops back down to 0, then to minus 340 volts. So your 240 volts RMS is like an average. So if you want to replace your PHCN power with a DC equivalent, you need 240 volts DC. That is what it means. But in actual fact, the voltage that comes from your public power supply is far above 240. It goes as high as 340, but only briefly. And remember that the frequency is 50 hertz, which is 50 complete cycle. This is one complete cycle, 50 of this in 1 second. So next, let's talk about how to measure voltage in a circuit. So how do we measure a voltage in a circuit? We'll be using a multimeter, but unfortunately, because we are not in the lab right now, we probably will just do a little bit. I'll do a little illustration of how you can make use of that. I don't have resistors with me here, and I don't have a breadboard with me here. They're all in the lab, but I was able to get my hands on a multimeter, so probably we'll not do it what we have here. So if I have a circuit, and in my circuit I have a voltage source, so let's stick with DC voltage source for now, but the same applies to if you want to measure voltage in an AC circuit. And this is a DC circuit because our power supply is a DC voltage source. Our voltage source is DC, not AC, so it's a DC circuit for that reason. The DC, I have a DC power source, and I connect it to a resistor. Now the question is, how do I measure the voltage across this resistor R1? Now we measure voltage across across a load or a resistor. When you're measuring voltage, you do it across. I underline the word across. So if it's voltage you're measuring, you will measure that you're measuring across. So let's see what I mean by across. Now if I want to measure a voltage across R1, I use what we know as a voltmeter. We know what the voltmeters are. So if I want to use a voltmeter, I connect it across this. So what that means is that this is the symbol of a voltmeter, the circle and a V. Now I take the positive terminal. The voltmeters have positive and negative terminal. I connect the positive terminal because this is the voltage terminal of the voltage source. I connect this to this and this to this. That is all. So whatever reading I get here would let me know the voltage, would determine the voltage, or would be a representation of visualization of the voltage across this resistor. So in other words, if I place my voltmeter here, this voltmeter, this representing my voltmeter, I take the terminals positive and negative terminal. I connect the positive terminal to one leg of the resistor and the other here. So the reading of the voltage across this will appear here. So sorry we don't have resistors here and a voltage source to implement this. We'll do all this when this pandemic period is over. We would practicalize all of this in the lab, but this is just giving you a preamble into what we'll be doing in the lab later on. If you are going to actually do actual readings, you'll see how this works, how the voltage across a resistor is actually measured. But I'm just giving you a little background, a little theory to what we'll be doing later on when the semester fully resumes. So that is how we measure voltage across a load or across a resistor. And then let's go to current. So how to measure voltage across, or measure voltage in a circuit, we've done that. So let's go to how to measure current. Let's go to how to measure current. Now you measure current not across. You don't measure current across. You measure current through. I underline the word through. So that is one major difference between measurement of current and voltage. If it's the voltage you're measuring, you do it across. You measure voltage across a load or across a resistor. But you measure voltage. Yeah, you measure voltage across a resistor. You measure current through a load or a resistor. So let me just explain how that works. Now, when I wanted to measure the voltage across this resistor, I just placed the voltmeter across the resistor. Now, if I want to measure current through, I will have to change this a little bit. So let me edit this a little bit to measure the current through R1. Let's assume that my R1 is still here. Let me place my R1 around here. So if I were to be connecting voltmeter to this, I'll just, as usual, just connect it this way. Connect the voltmeter this way. Voltmeter, yeah, as usual. But because I want to measure current through, now what I'll do is that I'll break the continuity a little bit. You measure current through. So your ammeter, we all know that we use your ammeter as a measuring instrument to measure the current. So this way, ammeter, like this and like this. So you place your positive terminal of your ammeter, you place it from positive, from the voltage source. Your positive terminal goes towards where your voltage source is, the positive terminal of your voltage source, and your negative terminal towards you point it, so you connect it to one of the terminals of your load or your resistor. So current will actually flow through. So that current comes from here, from the positive terminal of your DC voltage source, and it goes through the ammeter. It goes through it, then through the load, and then back to the negative terminal. So current flows through your ammeter, then through your resistor. So you measure current through. You measure current through, and you measure voltage across the load. So if I were to get my multimeter once again, I want to measure current, so I remove it from here, and most likely, since I'm just working with a small resistor, it will be in the milliamp range or the microamp range. So I place it here. This is voltage range. This is the ohmic range. That's if I want to measure resistance. This is capacitance range. This is Hertz frequency range. This is microamp range and current. So this is microamp, milliamp, and amps. So these three ranges are current ranges. So let's go to the microamp. So this is microamp. I turn it on. Now, if this were to be an actual circuit on a breadboard, and I want to measure current, then what I'll do is, let me clean this a bit. I want to replace my ammeter here with an actual implementation of the ammeter. I will connect this to one terminal of the voltage source, and the other leg I'll connect it here to one terminal, or the second terminal of the resistor, like this and like this. So I'm sorry we don't have a breadboard here. We don't have a resistor and an actual voltage supply, voltage source to experiment this, but this is just to give you a little background of the theory before we do the implementation of the practical a bit later on. So you see here that if I leave this out, if I open this is open circuit. If I open the circuit here, current will not be able to flow through the resistor. So the circuit is open. The circuit is not complete. So it's until I connect the ammeter across this and this here, the current will flow from the positive terminal of the DC voltage source through into the ammeter, from the ammeter through the negative terminal here, and then complete the circuit. So once you do that, you're going to have readings here showing your the current flowing through the circuit. So that's basically how you measure current through the load. So you connect your ammeter in series. So for current measurement, you connect your ammeter in series, and you connect your voltmeter in parallel. So those are the two major differences when using an ammeter to measure current through a load or a resistor, and when you are using a voltmeter to measure voltage across a load or a resistor. If it's an ammeter you are using to measure current through, then in that case you connect them in series. But if it's a voltmeter you are using to measure voltage across, then it's in parallel. So that is that about that. Now you can determine the resistance of an unknown resistor using a voltmeter and an ammeter. So if I have a resistor R1 and I'm not sure of the resistance of this resistor R1, and let's assume for some reason the color coding on the resistor had faded. Let's assume that the color coding on the resistor had faded, and let's assume that my multimeter does not have ohm range. It doesn't have the range for measuring the ohms, so the resistance of the resistor. Let's assume it only has the voltmeter range and the ammeter range, the current and the voltage range. How can I determine this? You simply use Ohm's law. To do that, I'll need if I have a known voltage source,